We're going to go over middle school, high school geometry, depends what school you're on, and it's just a real quick theory, or theorem. Okay, so let's look at our proportions here because this will help us understand the bisector angle theorem. Let's just go over this concept because when you get ready to do something called means and extremes, they will make sure that these multiply. So just remember that as you move on, 3 times 8 is 24 and 4 times 6 is 24. So 4 times 6 has to equal 8 times 3, which it does, and that's a great way to check your bisector angle theorem. And the inverse has to be true, so the inverse of this is 4/3 is 8/6. Then just keep in mind that this is still 3 times 2 is 6, and this is 4 times 2 is 8. So this is 24 equals 24. So the inverse is true of the original equation, and keep that in mind as we are moving on. Okay, so here's a bisector angle theorem. Means and extremes are able to determine how congruent segment lines and rays are in a triangle. So for instance, if angle A was 3 and C was 4, this would have to be like AD was 6 and this measure was 8, C to D was 8. This is a bisector. So even though it does not look even, it is still bisecting these into congruent triangles. And so when you think about this, you don't want to think about equal. You want to think about the word congruent. Meaning congruent, some people confuse with equal, but actually it means like equal in a way. It means like 2/3 is the same as saying like 6/9. Because 2 times 3 is 6 and 3 times 3 is 9. So that's congruency. And I'm going to go ahead and write this word, and those of you who are already taking geometry already know it. So that's all this really means. And then it gets into lower extreme and high extreme and this and that. We'll go over that on the page. But just understand that even though this looks a little crooked, this is basically this line here. I'm going to draw sideways, is a bisector. And once you bisect, you have congruent triangles on both sides. Okay, so you have some congruent lines. We already stated that. And we already went over this, but let's go over this. This is your first extreme, is your 3. Why is that? Because if you remember, this was A. And this over here was C. And this was B. And this was D. And letters don't really matter, but this would have been a 3. This would have been like an 8. And actually, your 3 would have been more like over here. Oops. 3 would have been here. 6 would have been here. And you see your congruency is going to get in line here, so this has to be a 4. So if you were writing your first congruency, or you were writing your first line, let's say you wanted to go AD. It's awful A. So if you wanted to go AD, so line AD is congruent, or is the first part of DC. And I'm just putting this over here, lines and rays, just to keep up with your teachers and them being consistent. And then these two are congruent to the other two. These two lines here, these two dots mean to say that they're the same, they're equal. So now you're going to do what two lines? You're going to do BC or AB. Well, that's all out. So AB, I'm drawing it bigger, is equal to BC. That's what they do, BC. Okay, so then if we did this, AD would be 3, DC would be 4, and this means it's a ratio. So that means that really this is like AD is 75% of like DC. You can get into that later. And then when you come over to this, they just want you to know this extreme concept is B. And then BC, AB is 6, 2, 8. And there, it's done. Just remember, this is a bisector. This one looks a little bit more even, but not always. Okay, and then this is a product rule. The product property of means and extremes basically says that the product of the means and the product of the means is equal to the extremes. So your extremes were these last. So once again, 3 to 4. This is one extreme. 6 to 8. This is your last extreme. So the products have to be equal, and you prove that with your congruent lines. Whoa, I'll do that. You prove that with your congruent lines when you went to do your ratios, right? All right, I'm gonna stop. I'm not the best drawer. Okay, so when you went to do your ratios. So now your 3 times 8 is right here, and your 4 times 6 is right here, and they were done for you. So the inverse has to be true as well, because we did inverse on the first slide. So if you invert 3 to 4, you would have 3 over 4. And then when you invert it, you would have 4 over 3. And this was pretty much done for you already. So this was done 4, 3. Your product's still the same. The product property means they still have to be equal. So this is 6 times 4. This was done for you. And 3 times 8. This is done here. That's 24. That's pretty much what they mean. Simple rule, simple thing. Thank you for watching.